everyone, welcome to another lecture on circuit theory. In this lecture, let us discuss problems on nodal analysis. During this presentation, I am going to cover three different problems. Problem number 1, calculate potential across the terminals of AC using nodal analysis. Problem number 2, calculate current in all the three batteries using nodal analysis. And finally, problem number 3, find the current in 7 ohm resistor using nodal analysis. Problem number 1, calculate potential across the terminals AC using nodal analysis of the following circuit. I am going to use KCL equations. Step 1, identify the principal node and choose one of them as a reference node. Right, I am choosing this point here where 4 different branches connected, so this can be a node, and I am choosing this point where once again 5 different branches are connected. In fact, I have to give a node number. Former one is node number 1, later one is node number 2, and coming to this point where we have 4 different branches, I can say this is third principal node. And also at the bottom there are 3 branches connected, which can be termed as fourth node. In fact, fourth node is called as reference node. Step number 2, label the node voltages with respect to ground. So coming to node number 1, V1, node number 2, label it as V2, node number 3, label it as V3, and node number 4, the voltage is V4 equal to 0, that is reference node. Have a look at last line of step number 2. We have to mark branch current direction for KCL equation writings. So coming to node number 1, we have 4 different branches connected together. So let's mark branch current direction for 4 ohm resistor downward I1 randomly. Similarly for 2 ohm resistor randomly I2, and 4 amps and 5 amps already current direction is marked, so no need to bother about that. Then coming to node number 2, so 4 amps branch and 2 ohm branch already branch current directions are defined. The rest of the branches we have to provide the direction of current. For 2 ohm, let me take down I3 downward direction. For 3 ohm, right hand side direction I4. I do not want to bother about 3 amps since direction already given. Then coming to node number 3, there are 4 different branches connected here. Among this, 3 of the branches already having current direction and 5 ohm alone not having. Let's fix the direction for 5 ohm as I5. So all these directions are chosen randomly. Step 3, write down nodal equation at all principal node except reference node. Coming to node number 1, there are 4 different branches connected. Among this, 5 amps currents alone towards a node, remaining 3 branches away from the node. By applying KCL, we may write incoming current is equal to outgoing current, that is 5 amps is equal to I1 plus I2 plus I4. 5 amp is the only incoming current, I1, I2 and 4 are outgoing. Now, how to write current I1, I2 in terms of voltage and resistor? Let us see now. I1, where I have I1? Between node number 1 and 4. So from 1 to 4, we can say V1 minus V4 divided by the corresponding resistance on this path, 4 ohms. Whereas V4 is assumed to be 0, that is why V1 minus 0 by 4. Current I2, that is flowing between node number 1 to 2. So it is starting from 1 towards 2, so that V1 minus V2 by 2. Upon simplifying, you may get 0.75 V1 minus 0.5 V2 is equal to 1 as equation number 1. Moving to node number 2, there are 5 different branches connected. Look at incoming current I2 and 4, 2 incoming current. So 4 plus I2 is equal to outgoing current I3, I4 and 3 amps. Sum of all these 3. Then write down each current term in terms of voltage and resistor. For I2, you can copy it from the former equation number 1, that is V1 minus V2 by 2. Coming to I4, flowing between V2 and V3. So V2 minus V3, on this path I have 3 ohm, hence denominator 3. Coming to I3, flowing from 2 towards 4, so V2 minus 0 divided by 2. Finally, upon simplification, you may get 0.5 V1 minus 0.133 V2 plus 0.33 V3 is equal to minus 1 as equation number 2. Then, moving to node number 3, I have 2 incoming current, namely 3 and I4, and 2 outgoing current I5 and 5. So 3 plus I4 is equal to I5 plus 5. Now write down I4, I5 in terms of current equation. I4 you can copy it from the previous equation number 2, that is V2 minus V3 by 3. For I5, look at current flowing between 3 and 4. So V3 minus 0 divided by 5 ohm. Upon simplification of this equation, you may get 0.33 V2 minus 0.53 V3 is equal to 2 as equation number 3. Then step number 4. Solve the nodal equations obtained in step number 3 in order to find out node voltages. So we got 3 equations. Solving this using calculator or manually, you may get V1 as 1.6884, V2 0.5326 and V3 as minus 3.442 volt. Let's go back to the question. Calculate the potential across A and C terminal. Look at A and C terminal. Potential across A and C is V1. It is enough to calculate V1. So voltage across terminals of AC is V1, which is 1.6884 volt. Let me move on to method number 2 using matrix inspection method. I'll take the same problem. Step number 1, convert all voltage sources into current sources and identify principal node. Also choose one of them as a reference node. So according to the circuit, there is no voltage sources. So as like previous problem, we can identify nodes. So already we have identified node. Straight away let me fill that. Step 2, label the node voltages with respect to ground. So let me identify V1, V2, V3 and V4 are the different node voltages. Among this, V4 is reference node, assumed to be 0. Then step number 3, formulate network equation and solve it. So I have 4 principal node here. While formulating equation, I is equal to 1 by R into V, where I is current vector with the dimension of n minus 1 cross 1. 1 by R is inverse resistance matrix n minus 1 cross n minus 1, and voltage vector with the dimension of n minus 1 cross 1, where n is number of principal node. Hence, I am getting current vector I1, I2, I3 as well as voltage vector V1, V2, V3, the inverse resistance matrix 3 cross 3 dimension. Let me consider node number 1. 5 amps currents towards the node, I got plus 5. 4 amps current away from the node, so minus 5. Incoming current with plus sign, outgoing current with minus sign. Similarly, look at node number 2. 4 amps currents towards the node, so plus 4, and 3 amps current away from the node, so minus 3. Similarly, look at node number 3. 3 amps current towards a node, and we got plus 3 here. 5 amps current away from the node, minus 5. So this is how to fill current vector. Then coming to node number 1 again, identify how many resistive branches linked with it. 2 ohm and 4 ohm. Go for inverse sum of these two values, that is 1 by 2 plus 1 by 4. Similarly, go to node number 2, identify the resistances linked with this 2 ohm, 2 ohm and 3 ohm. So R22, you fill R1 by R22 as inverse of sum of these values. Similarly, go for the third node, 3 ohms and 5 ohms connected with this. So third diagonal element may be sum of inverse of these two resistances. Then coming to R1 to 2, between node number 1 and 2, what is resistance connected? 2 ohm. So go for minus 1 by 2. It's minus sign as per rule. Similarly, R1 to 3, there is no element is connected, so straight away take down 0. R2 to 3, between 2 and 3 there is 3 ohm branch, so take down minus 1 by 3. This inverse resistance matrix is symmetrical matrix, so R1 to 2 becomes R2 to 1, R1 to 3 becomes R3 to 1, and R2 to 3 becomes R3 to 2. Simplify this network, you may get 1, 1, minus 2 as a current vector and a simplified version of inverse resistance matrix. Now let's find out V1, V2, V3. Step number 4, solving the network matrix equation. You may find out all the 3 node voltages, but I am calculating V1. V1 is del 1 by del, where del is determinant of inverse resistance matrix, this inverse resistance matrix, and del 1 is determinant of inverse resistance matrix, but the first column alone replaced by your current vector, this current vector. Then find out determinant of both numerator and denominator and divide it. You may get final answer as 1.6684 volt. Now go back to the question. Calculate potential across terminals AC using nodal analysis. AC, look at the terminals AC. Voltage across AC is V1. That is the reason why I am finding V1 alone, which is 1.6684 volt. Problem number 2, find the current in all batteries using nodal analysis. Have a look at the circuit. I have 5 volt battery here and here and also here in this loop. I have to find out current in all the 3 batteries using nodal analysis. I am going to use KCL equation method to solve this problem. As usual, identify principal node and choose one of them as a reference node. This point is not a principal node. This point can be a principal node since 3 or more branches connected. Let me take down this as a node number 1. Then this point is not a principal node since 2 branches connected. Even this point is not a principal node. This point can be a principal node since 3 branches are connected. Let me take it as node number 2. And this point as well as this point not a principal node. This can be a principal node since 3 branches are connected together. I will take down this as a reference node. Step number 2, label the node voltages with respect to ground and also mark branch current direction. Node number 1 has V1 as a voltage, node number 2 has a voltage of V2, and node number 3 has a voltage of V3 since this is reference node, this is equated to 0. And look at this line, also mark branch current direction. Let me randomly mark the branch current direction here. This is I1 and here I2 downward direction, upward I3, and this is I4. So node 1 has 4 branches, all the 4 filled with current direction. But node number 2 have 3 branches, among these 2 already been filled, third one is filled by I5. Then step number 3, write the nodal equation at all principal node except reference node. Apply KCL at node number 1. Have a look at node number 1. There are 4 branches linked with it, so has 4 branch currents, namely I1 to I4. Among this, I1 alone towards a node, I2, I3, I4 are away from the node. Hence, I1 equal to I2 plus I3 plus I4. Writing the equation for I1, I1 is flowing between V3 and V1, starting from V3 towards V1. So V3 minus V1. Then on this path, I have a 5 volt source, current leaving positive of the 5 volts, so plus 5. Coming to the denominator, I have 2 plus 2 resistor on this path. So take down 2 plus 2. This is what I is equal to V by R, that equation. Then coming to I2, which is flowing between node 1 and 3. So V1 minus V3 divided by 1. Then I3 is flowing between V1 and node 2, in fact V2. So V1 minus V2. On this path, once again I have a 5 volt source, current leaving positive of the 5 volt source, plus 5. Once again on this path I have 2 plus 1 plus 1, hence 2 plus 1 plus 1 on the denominator. Finally, I4 flowing between V1 and V2. So V1 minus V2, denominator you have 2 ohm. Now substitute the values for a reference node, which is equal to 0, and then simplify this equation. You may get 2V1 minus 0.75 V2 is equal to 0 as equation number 1. Then from node 2, you may write down the equation. There are 3 branches and so as 3 currents. Among this, I3, I4 towards a node, I5 away from the node. So here writing equivalent voltage equation, that is node voltage equation, is quite simple. Already we concluded I3, I4 equation earlier. You simply copy those equations here. Then only job is to write down I5 equation. You go for I5 flowing between V2 and V3. From V2 towards V3. So V2 minus V3. So look at 5 volt source I am having. So current leaving negative of the voltage source, so minus 5. Denominator we have 2 plus 2 ohms. Then as usual substitute the values for V3 and simplify this equation. You may get 0.75 V1 minus V2 is equal to minus 2.5 as equation number 2. Step 4, solve these two equations and get the value of V1 as 1.3 volt and V2 as 3.47 volt. Then find the current in each battery. This is your actual question. Current in battery 1. Let me identify what is battery 1. This is battery E1 and this is battery E2, and here finally battery E3 according to my assumption. Battery E1 has a current of I1, which is already calculated here in terms of equation. Then the same equation is written here substitute the values for V3 and V1. In fact, V3 value is 0. You may get the answer as 0.925 amps. Then current in battery E2. Let me go back to the problem once again. Current in battery E2 is I3, which is also identified in terms of voltage and resistance. Substitute the values here for voltage V1 and V2. Then you may get the solution as 0.7075 amps. Then current in battery E3. Look at this. I5 is a current in battery E3, which is also identified in terms of nodal voltages. Substitute nodal voltages here. Finally, you may get the answer as minus 0.3825 amps. The minus sign indicates that current is flowing in the opposite direction of Ashimi direction. So this is how to solve problem using KCL. Take method 2 as a homework and check the answer. Finally, come to problem number 3. Find the voltage across 2 ohm resistor using nodal analysis. I am going to solve this problem using matrix inspection method. This is a given problem. We have to find out voltage across 2 ohm. Here we go, 2 ohm resistor, where we have to find out voltage across the resistor. Then, as usual, go for a step number 1. Since I am going to use matrix inspection method, I want to make sure that all sources belongs to current source. So I have one voltage source here. I have to convert the voltage source to current source. So I have converted here. Have a look at this portion. Voltage source in series with resistor has been replaced by current source in parallel with resistor. Resistor value, blindly you copy it, but current value I is equal to V by R, where V is 5 and R is 4. So 5 by 4 is 1.25 amps is a current source. Identify principal node now. This is going to be a principal node since 3 branches are connected. This is also going to be a principal node, second node, where 3 branches are connected. So this can be a principal node, but we have too many points here. You can pick one among this. I'm choosing this point where 5 branches meeting. So node number 3, and as usual, I'm going to the bottom where I have more than 3 branches connected, so I can choose it as 4th node. In fact, 4th node is a reference node, so make it as 0 volt. Then simply label node voltages. Node 1 has V1, node 2 with the voltage of V2, and node 3 with the voltage of V3. And V4 already been defined as a reference node and made it as 0 volt. Then step number 3, formulate network equation and solve it. As usual, I is equal to 1 by R into V. I with the dimension of n minus 1 cross 1, that means 3 cross 1, one inverse matrix with the dimension of 3 cross 3, and voltage vector with the dimension of 3 cross 1. Now substitute the values for each and every case. Go to node number 1, fill current vector now. I1, 2 amps towards the node, so plus 2. Moving to node number 2, there is no current sources connected with this, make it as 0. Then node number 3, 1.25 amps towards the node, plus 1.25, and 2 amps away from the node, and hence minus 2 amps. So current vector has been filled. Now once again go to node number 1 to fill inverse resistance matrix. How many resistive branches linked with this? 5 ohm and 1 ohm, 2 branches. So go for inverse of sum of these two values, 1 by 1 plus 1 by 5. Then moving to second node, in order to fill second diagonal element, there are 3 branches linked with this, 5 ohm, 2 ohm and 7 ohm, and go for inverse of sum of these 3 values. Then moving to node number 3 to fill final diagonal element. There are 3 resistances, namely 3 ohm, 4 ohm and 7 ohm are linked with this. Similarly, inverse of sum of these going to be third diagonal element. Then, in order to fill off diagonal element, refer the first one, R1 to 2. Between 1 and 2, what is the element resistance connected? 5 ohm is connected. So in place of R1 to 2, you go for 5. That means minus 1 by 5. Then 1, 2, 3. 1, 2, 3, no straight connection through resistance. So make it as 0. And 2 to 3. Coming to 2 to 3, we have 7 ohm between node number 2 to 3. So make it as minus 1 by 7. And once you filled these 3 values, this inverse resistance matrix is symmetrical matrix. So you copy R1 to 2 as R2 to 1, R3 to 1 as R1 to 3 and R2 to 3 as R3 to 2. And simplify this, you may get a simplified version of matrix. Solve the matrix and find out V2, where V2 is del 2 by del. Del is that inverse resistance matrix and del 2 is the same inverse resistance matrix except that these 3 elements replaced by current vector. This is your current vector and this is your inverse resistance matrix. Find out determinant of numerator and denominator. Finally calculate V2 as 0.2397. So voltage across 2 ohm is also 0.2397 since voltage across 2 ohm is V2. And so as V2 is represented here 0.2397. I hope you understand all the 3 problems. For more update, subscribe my channel.